Hey, have you noticed that if you write something in Google, it automatically suggests you what you might be looking for? Well, this thing, among with others, is based on tries. Trie is a tree-like data structure, so it has something called root, which is at the top. Yes, in informatics, roots are at top. Also, every node can have something called child. Child is the node directly under its parent, and child node can also have childs. For example, the first node in second row have two childs, and if node have no childs, it's called leaf. Now, let me show you how these nodes look like inside. Every node have references to its child, and since every node represents some character and prefix, to match the node and character, we will use something called map. If you don't know what that is, imagine that you have a table and each record contains character and corresponding node. Also, since the is word but also can be prefix to there, we have to be able to decide whether this word is in our tree or whether it is just a prefix. That is why we have Boolean variable which indicates that. Let me show you how you can add words. I got here my root node and words I want to add. So, let's add car. As I said before, every node represents one character of some prefix. So we split this word into characters and add to our tree prefix for every word starting with C. Inside this node, we want to add a node that represents all words starting with CA. So we add A into its map and create a new node. So this new node represents prefix CA. As you probably figured out, we add to its map R character and create a new node. This node represents all words starting with car. Since we want to add this word, we set its indicator to true. Let's try to add done. So, once again, we start at root and look at its table and see that we don't have any node representing the prefix. So we create one and add new record to root's map. In this new node, we look for O. Since there is no O in our table, we add it and create a new node which represents do prefix. In this node, we continue with N, where the same thing happens as we create new node for done prefix. In this node, we add E and once again create new node. And since we have no other characters in done, we set this node's word indicator to true, and we are done. Let's try to add try. Once again, we look at root and try to find T in its map. But T isn't there, so we create new record for T and add to it corresponding node. We move to this node and continue with next character, in this case R. Since this node map is empty, we add there R and create new node representing TR prefix. And we add to this node Y record. And once again, we create corresponding new node. This node represents prefix try. And since this is the word we want to add, we set its word indicator to true. Now, let's add cat to our tree. So we look at root. But we find out that C is already in our roots table. So we move to node representing C prefix. And in this node's table, we look for A. A is already there, so we move to corresponding node. In this case, we look for T, and we find out that T is not in our node. So we add T and create new node. And because we have no other characters in cat, we set the word indicator to true. Let's add try. We look at root's table and find out record T is already there. We continue with corresponding node. In this node, we find R and move to node representing TR prefix. Now we look at I in this node. Since it's not there, we create new record for I and new node for try prefix. Since we still have one character left, we create new record for E and new corresponding node. In this node, we set the is word indicator to true. Let's add our last word, do. We look at root and see that D is already in the table. so we follow its pointer. Now we try to find O in this node. O is in this node, so once again we follow its pointer. Since we have no other characters to follow, we set the isWord indicator of this node to true. Let's try to find some words. First word is CA. Remember, each node represents prefix, so we start at root and look for prefix C. We follow C's pointer, and in this node's table we are trying to find A, because in order to find CA, we need to find CA prefix. A is in table, so we follow its pointer and get to node which represents CA prefix. So we look at its word indicator, and since it is false, this word is not in our tree, even though we found corresponding prefix. Let's try to find zebra. So we look at root's table and look for Z. Since Z is not in there, there is no way that zebra is in this tree. Actually, because Z is not in root, we can say that any word starting with Z is not in this tree. Let's find try. In this root's table, we found T record, so we follow its pointer. In this node, we continue with R. Since R is in this node's table, we follow its pointer and get to node which represents TR prefix. In this node, we look for last character I. I is in this table, so we follow its pointer. And since we have no other characters left in our word, we look at this node's isWord indicator. Since it is true, we can say that try is in this tree. Let's try to find card. We start at root and follow C. Then we follow A. We still have 2 characters to go, so we continue with R. We get to node which represents card prefix and look for D in its table. Since it is not there, card is not in this tree. Let's try to delete some words. In order to delete a word, we need to find it. If this node have child nodes, we cannot delete it. So we just set the isWord indicator to false. But if this node have no childs, we can delete it and then check if we can also delete the nodes above. So let's delete do. We look up do and see that the node representing do prefix have child. So we just set the isWord indicator to false. Now let's delete try. We look up try and see that this is a leaf. In other words, it has no child. So we delete it and also delete the record that points to this node in node above. Now we see that the node above also have no child nodes, so we can remove it too. And once again, we also remove the reference in node above. Now we try to delete node above, but it have a child, so we cannot delete it. That means we are done. Let's try to delete CA. We look up CA and see that the isWord indicator of this prefix is false, and we cannot delete something that is not in the tree. So we are done.